going on, okay? All right, so like I said yesterday, we finished equilibrium and we are done with that. There is homework for that, which I don't think I managed to assign, but I will. And then we're going to start today by going over the spring break homework. So I am going to share my screen. And these are the answers to the multiple choice. So let's start with that. So check your multiple choice, and then you will have the opportunity to ask questions about them. Good girl. Okay, Jean, do you need another minute? Okay. How are we doing now? Do we still need more time? Okay, let me put it this way. If you need more time, please say out loud with your mic unmuted, yes. Okay, then I'm going to assume that everybody has had a chance to go through these. So we're just going to take this one page at a time. So are there questions on the first page, which is questions 1, 2, or 3? And again, you're going to have to like talk out loud because I can't see everybody. So we're good with 1, 2, and 3? All right. The next page is 4, 5, 6, 7. Questions on that?
Can you go through 7?
7, sure. And my dog is looking at you funny, Dagny. Just because my computer talked. All right, so 2 objects are dropped from rest at the same height. This is number 7. Object A falls through a distance dA during time t. Object B falls through a distance dB during time 2t. If air resistance is negligible, what is the relationship between dA and dB? So I kind of started by making myself a picture. Just to make things easier, I assume that both objects started from the same height. And here are my times at t and 2t. So this object falls dA and this object falls dB. Okay, so they're both dropped from rest. So they both have v0 equal to 0. The acceleration is g in both situations, so we'll let positive be down. And the mass doesn't matter because mass doesn't matter if I'm neglecting air resistance. So what I did was I made a list of knowns for both of these. So like I let this be y equals 0 up here. So that means that y0 is 0, y is dA, v0 is 0, I don't know what v is, a is g, and t is t. And for object B, I have y0 is 0, y is dB, v0 is 0, I don't know what v is, a is g, and t is 2t. And then it looks like what I decided to do was to kind of solve for t. That would be because I know that t and dA and dB are all going to be related. So if I look at each of these problems separately and come up with an expression for t, I can set those expressions equal to each other and then have a way to relate dA and dB. So I really only have enough information for y is equal to y0 plus v0t plus 1/2 at squared. So this is 0 and this is 0. So this is dA is 1/2 gt squared, or t squared is 2dA over g. Does that make sense? Understand where that's coming from? Dagny, I've lost you.
Yeah, that makes sense.
And then I can do the same thing for object B. I've got y is equal to y0 plus v0t plus 1/2 at squared. And again, it starts at y equals 0. It starts from rest. So that gives me dB is 1/2 A, and here's the, or 1/2 G, and here's the tricky part, it's 2T, but that whole 2T is squared. Okay, so that gives me dB is 1/2 G times 4T squared. So over here for object 2, T squared, that's going to cancel, is going to give me dBg over 2. Yeah, I think that's right. So if I set my T squareds equal to each other, then I've got 2dA over G is dBg over 2.
Dr. Goetz?
Yes.
Oh, would it be dB over 2G?
Oh, yes. Thank you. It would exactly be that. That's what happens when I don't look at my notes. So my G's are going to cancel. And now this is the point where I would look up at my options. Okay, since it's a multiple choice question. And all of my options are dA equals something in terms of dB. So I would solve this for dA. So I've got dA is then dB over 4. Okay, makes sense? All right. And again, you don't have to write down everything that I wrote down. I'm writing down enough to explain it to you. If you can get away with less, if you can put more in your picture so that you don't actually have to make a list of your knowns, that's fine. With a multiple choice question, the goal is to write down the least amount that you can and still get the problem right. Okay, questions on 4, 5, and 6? All right, then we'll move on to the next page, 8, 9, 10, 11, 12, 13.
Can we go over 13?
Sure. So 13 says, a block slides from rest with negligible friction down the track above, descending a vertical height of 5 meters to point P at the bottom. It then slides on a horizontal surface. The coefficient of friction between the block and the horizontal surface is 0.2. How far does the block slide on the horizontal surface before it comes to rest? Okay, so I'm just going to very quickly kind of sketch everything here. So this is going to be point P. My block of mass M is going to start up here. This is going to be H is equal to 5 meters. And then basically I'm going to kind of let this be X equals 0. And over here somewhere where my block comes to rest is going to be some value of X. Okay. Now, this to me screams conservation of energy. Okay, we have a certain amount of potential energy up here at what I'm going to call position 0. All of that potential energy is converted into kinetic energy, especially if I decide that I'm going to let UG be 0 at the bottom, which I would. Okay, so all of that gravitational potential energy at 0 is turned into kinetic energy at P. And then that kinetic energy at P is turned into thermal energy at, we'll call this X equals D at point. Okay, so remember about conservation of energy is that I can take any two of those positions and set things equal to each other. So I don't have to know anything about the energy at point P. I can look at all of the potential energy at point 0 and know that it is turned into thermal energy at D. Okay, makes sense to everybody? So I'm going to say that E0 is equal to ED. Like I said, at E0, it's all gravitational potential energy. And at ED, it's all thermal energy. And thermal energy is the work done by friction. So the work done by friction is going to be the friction force times the distance that that friction force acts over. And because, and I know that the friction force is always mu times the normal force. And I could draw a little free body diagram over here that says my gravitational force goes down, my normal force goes up, my friction force goes this way. That's okay. All right. And so from that picture, I know that the normal force is going to be equal to the gravitational force. Again, maybe you don't need a free body diagram, and that's okay. It's a multiple choice question. You do what you need to do. So this is going to give me mu mg times d. My mg's cancel. So d is going to be equal to h over mu. So that's going to give me 5 meters divided by 0.2, which should be equal to 25. Did anybody do this a different way? Lauren, what did you do?
I said I used energy as well, but instead of equating each of the 3 points, I equated the point 0 with point P, and then so that would give mgh equals 1/2 mv squared. So I could solve for the speed at the bottom, and then I drew my free body diagram with F net equals ma to solve for the acceleration, and then used the speed and acceleration in the equation v squared, v final squared equals v initial squared plus 2a times the distance that it traveled, because the final speed is 0 and the initial position is 0.
Excellent. So that is a perfectly valid way of doing it. And if that's what occurred to you, then that's what you should do. Great. Any other questions on 8, 9, 10, 11, 12?
Can we go through 10?
10.
Oh, Dr. Goetz, sorry,
Yeah.
just really quickly, while we're still on this question, for the energy at point 3, it was the force times the distance. Is that because the work equals the F dot D?
Yes, the thermal energy by definition is equal to the work done by the friction force. And because friction is a constant force, work is equal to F dot D. There's probably some kind of negative sign in there, but when we're talking about the work done by friction in a situation like this, we take the absolute value of that, because the minus sign tells us that the work is leaving the object, which is true, but I still have to account for it. So it has to be a positive thing. Okay.
Thank you so much. Sorry, I didn't mean to interrupt.
No, it's good to talk about it before we leave. Okay, so number 10, right? Is that what you said, whoever it was?
Yep.
Okay, so a particle of mass m starts from rest at position x equals 0 and time t equals 0. It moves along the x-axis under the influence of a single force. Fx is equal to bt, where b is a constant. The velocity of the particle is given by, okay, So this is actually calc, all right? Because if the only force acting in the x direction is this Fx, that's going to be equal to ma. Now, obviously, the acceleration is not equal to a constant because the force is not equal to a constant. But the acceleration is always dv dt. So now what I have is bt is equal to m dv dt, which is a differential equation that you can solve. So I'm going to put all my terms that have dt's on one, I'm going to put all my t's and my dt's on one side and all my v's and dv's on the other. So basically I'm going to have b over m t dt is going to be equal to dv. Now we do it this way because I want to solve for v. Could I leave that m over there next to the v? Yes, and just divide by it later because it's a constant. But this is, it's just a way to do it. So I'm going to integrate both sides. And on one side, since I know it starts from 0, I'm going to integrate from 0 to whatever the velocity is. And on the other side, I'm going to integrate from t equals 0 to whatever the time is when I'm measuring that velocity v. Okay. So what's the antiderivative of dv?
V.
V. Okay, and I'm going to evaluate that from 0 to v. On the t side, I can pull out the b over m because it's a constant. And then what's the antiderivative of t dt?
T squared over 2.
Yep. And again, I'm going to evaluate that from 0 to t. So that's basically going to give me 1/2 b over m t squared is equal to v. And that is, in fact, what the answer is. Okay. Questions on 8, 9, 11, 12?
Could you talk about 8?
What did you say, Fiona?
Could you talk about 8?
8. Okay. Number 8. So number 8 says the maximum mass that can be hung vertically from a string without breaking the string is 10 kilograms. So that means that my maximum tension is equal to that weight, or 10 kilograms times g. A length of string that is 2 meters long is used to rotate a 5 kilogram object on a circle on a frictionless table with the string horizontal. So I've got a circle, I've got my mass out here, which is 0.5 kilograms, and this string is 2 meters. The maximum speed that the mass can attain under these conditions without the spring breaking is most nearly. Okay, so what's going on here? What kind of motion is this?
Rotational.
It is, but it's actually a very specific kind of rotational motion that we learned about long, what?
Centripetal.
It's centripetal, okay? So remember, centripetal means that F is equal to MAC. And what's AC equal to? Anybody, what's AC equal to?
V squared over r.
Yeah. v squared over r, where r is the radius of that circle. Okay. So we need to know what force it is that's supplying this centripetal acceleration. So what's the force that's making the object move in the circle? We did this in class. If I hold the string and I have the object and I spin it around over my head, what's the force that's making that object move in a circle and not just fly off?
The tension.
The tension. Okay, plus it's the only other force they've told you about. Okay, so this tension is what's supplying the force to make the object move in centripetal motion. Again, we're talking about superlatives here. What's the maximum speed that my object can have without breaking the string? That means I want to consider the maximum tension. Okay, so the maximum tension is going to be, I'll write it this way because I don't want to mess it up. Okay, so that's going to be 10 kilograms times g. This m is half a kilogram because it's the mass that's actually going around in a circle. And then r is actually 2 meters. Okay. Now, usually in problems like this, they want you to assume that g is equal to 10. Okay, because for many years, you were not allowed a calculator on the multiple choice section of the AP exam. So everything was equal to 10 or 2 or a half or 4 so that you could easily do the math. Okay. So this is going to give me my 10 kilograms, my 10 meters per second squared. This is going to be a half times v squared divided by 2. So if I do the math right here, that should give me v squared is equal to 400. Or v is equal to 20. Okay, we good? Any other questions on this page? 9, 11, 12. Okay, then we'll go on to the next page. 14, 15, 16, 17. We're all good with 14, 15, 16, 17? Awesome. Next page, 18, 19, 20, 21. Okay.
Can we do?
Oh, yeah,
Sorry, can we do 20?
sure.
Thank you.
Okay, so Number 20, a certain one-dimensional conservative force is given as a function of x by the expression F is equal to negative kx cubed, where F is in newtons and x is in meters. A possible potential energy function U for this force is. So you have to remember that F is equal to negative du dx. Okay, so that's step one. So that means that du is equal to negative f dx. And if I integrate both sides, that gives me u is equal to negative of the integral negative kx cubed dx. So my negative signs cancel. K, the antiderivative of x cubed is x to the 4th over 4. There might be a plus c. Put it down there on principle. And then you just want to compare that with the answers, and they're obviously not worried about a plus c. So D is going to be your answer. Okay. Anything else on this page? 18, 19, 21. All right, the next page, 22 to 26.
Can we go over 26, please?
Sure. 26, two 4-kilogram blocks hang from a rope that passes over two frictionless pulleys, as shown in the figure above. What is the tension in the horizontal portion of the rope if the blocks are not moving and the rope and the two pulleys have negligible mass? Okay, so what do pulleys do if they have negligible mass? What is the only thing pulleys do?
They redirect the force.
Right, they redirect the force. So what I can do is I can take this system that has my rope and my two masses, and I can just pull those masses up. So that effectively what my picture is my 4-kilogram mass over here and my 4-kilogram mass over there. Okay, the pulleys are somewhere in the middle. And then basically this is my FG. Okay. Because all I'm doing is I'm like unfolding it, I'm bending it up. But FG is still the force that's pulling down on the masses. So, whoops. So if I take any one of these blocks, I'm going to have FG, which is mg, and I'm going to have my tension pulling in the other direction. Remember, number one, that a rope only has one tension, so it doesn't matter which of those blocks I choose. And then this is actually an equilibrium problem that we were talking about earlier this week. So that tells me that F net has to be equal to 0, or the tension has to balance out that gravitational force. And so again, my mass is 4 kilograms, and usually in this in the AP exam, you're assuming that the that the acceleration due to gravity is 10 meters per second squared. So that's going to give you 40.
Okay, thank you. I thought that you would take both, you'd sum the two tensions.
Nope.
Okay, thank you.
Sure. So like everybody's good with 22, 23, 24.
Can we go over 25, actually?
Sure. All right, so a block of mass m is pulled across a rough surface. Rough surface means there's friction. Coefficient of friction is mu k. The force that pulls the block is exerted at an angle phi. Which of the following is the expression for the magnitude of the friction force? So here's my block. Here's my applied force. I have mg going down. I have my normal force going up. I have my friction force going that way. Okay. And this is going to be some angle phi. So if the block is moving at a constant speed, so v equal to a constant, you don't have to, you wouldn't write this down in the exam, but you got to think about it, means a is equal to 0, means F net is equal to 0. So if F net is 0, my forces have to balance. So that means N plus F sine phi has to be equal to mg. And that means that F friction is equal to applied F times cosine phi. So F cosine phi is not an answer. So I've got to think about this a different way. I also know that my friction force is mu k times n. So I know from up here that n is equal to mg minus n sine phi. So that means another way to express my friction force is mu k times ng. Sorry, wait a minute. That's an F, not a N. Minus F sine. Okay. I think the tricky part is remembering that the normal force is not equal to the gravitational force in this situation. Okay, so I'm going to stop sharing here. You have to be somewhere at 10. We all have to be somewhere at 10:05. Are we going to Miss Stothard's? Okay, so we all need to go to Miss Stothard's Zoom. We will finish going over this tomorrow, and we will do some other things that we start our review with. Okay, so see ya.